So in this video here, we're going to learn the simple step in graphing for the absolute function, where in here, the absolute functions that we want to refer is happen to be in the form of fx equals to a multiply mx plus c plus k, where the a is mainly referred to the sign that we need to refer on the modulus. So go on. So what is the simple step that the simple steps in graphing that we refer is that we are referring to the type, the shape, the special point or line, intercept, and also graph. So in this case here, we begin with the first one, the type of the functions that we have for this case here. So the type of function that we refer is that we would like to have the absolute function in the form of, inside the modulus, we have it just the linear function mx plus c. Outside of the modulus, we don't have any x term. I can have constant plus k. I can have a constant multiplied with the modulus. So below are some of the examples that we can see that is corresponding to this form here, like modulus 3x plus 2 minus 5. Inside the modulus, you see is linear, 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 linear. Then outside of the modulus, you won't see any x term. You may have a plus k constant like here, negative 5, positive 3, 0, 0, positive 7. Or you may have a constant, happens to be positive value or negative value, multiply with your modulus. Like in the first case here, the a is corresponding to positive 1. The second case, negative 1, positive 1, negative 1, positive 2. So these are all the examples that we can make use of the step that I introduced here to sketch the graph. Next, we want to determine the shape of the graph. So basically, we have two types of shapes that we have, and you need to remember the first one as a guideline. By right, the rest of it will be just simple, can be simply derived from the first one. Where this first one here is happens to obtain when the time you have your a here, which is the constant that multiply with your modulus, is happen to be greater than 0. In other words, this implies to I have positive modulus. I have positive modulus. And in order to determine the shape of the modulus graph that we have, you find out that we will only focus on the sign on the modulus, which means that I'm going to mainly base on the sign of the a to decide the answer. So this is happen to be the shape that I have positive modulus. The sign of the m is not important here because let's say you have this shape here is for the case of positive x. If I want to have the case of negative x, what you do is that you flick this V shape here horizontally, you still get back the V shape. That's why the m here doesn't play any important role to decide the shape. We just focus on the sign on the a. And the examples that we can have for this case here, where we have a V shape is, for example, like you see here, I have positive coefficient for x and positive sign that multiply with modulus. At the same time, also, I can have negative coefficient of x and positive sign on the modulus. And once again, as you can see from these examples here, the important thing is that our modulus sign come with positive coefficient. Positive on the modulus is the one that decide the shape. Then next, I have another alternative shapes that I can have for this type of functions here, where just now we have the case of positive modulus. Now, what if I refer to the negative case of the modulus? So I will have this graph here with flip vertically. So when the time we flip vertically, the shape that I suppose I have will happen to be an inverted V shape. And the examples, as you can see, the main focus is on the negative sign. It happens to be occur on the modulus. The coefficient of x is positive or negative, it doesn't make any much difference. So with the idea here, then we go on with the next part, step 3. In this case here, we have a special points, the curves. for the absolute value function. So the curves here is referred to this sharp point here, And how we happen to obtain the coordinates of these curves here is that we base on the mx plus c here. We make it equal 0 to find out the x coordinate. Then the y coordinate just refer to the corresponding k here, as stated here. So as you can see, when the time I want to find the curves for each of these example function here, the x coordinate, I refer to 3x plus 2 equals 0. It gives me x equals to negative 2 over 3. 4x equals 0, it gives me x equal to 0. 3 minus 5x equals to 0, it gives me 3 over 5 for x. Here, it gives me x equals 0. X minus 1 equals 0, it gives me x equals to 1. And the corresponding y coordinate is just referred to the constant, k that you can see. So in here, it's just plus 0, plus 0, plus 7. So this is the idea that we can have for our special point. And once again, the importance of the special point is that it happens to let us to proceed into step 4 to tell that the x and y intercept whether exists or not. And then the next thing, it can also tell us what is domain and range. Just from the shape here, after you know this special point. Continue. Let's say we find out the x and y intercept happen to be exist, then the calculation will be based on x equal to 0 for y intercept. The x intercept, we will let fx equals to 0, or we just simply have y equal to 0 lah. Usually, this one we're going to solve by using calculator so that we have easiest, quicker answer. Because sometimes this one is difficult to do calculations. Go on. In order to know the existence of the x and y intercept, we can do a rough sketch based on the shape and special point that we obtained on the previous part. And this one we will see further in our example later to have a better understanding. Then at last, with all the information we have, we sketch the graph and make sure you do label the xy axis, the origin, label the graph, the vertex, and also xy intercept if they happen to exist. So this is the general idea that we're going to have on the graph sketching for the case of absolute functions. By the way, in this slide here, I think there is an error here. By right, this is supposed to be a modulus mx plus c plus k. This is the one that we refer, the modulus function. Okay, so the next video, we will refer to the examples for the absolute value functions.